Hello everyone. Today we will discuss the momentum equation and one of its main applications. At the end of this video, you will be able to clearly state momentum equation and will also be able to calculate the force exerted by a flowing fluid on a pipe bed. Now what is the momentum equation? According to Newton's second law of motion, the summation of forces in any direction is equal to mass into acceleration in that particular direction. Now that can be written as m into acceleration is dv by dt. That can again be written as d by dt of mv, because practically since m is a constant, it can be taken inside the differential. I can rearrange this equation and write as summation of the forces in any direction is equal to rate of change of the momentum in that direction. M into v is the momentum. So practically summation of forces in any direction is equal to the rate of change of momentum in that direction. This equation is termed equation number 1 and it is known as the momentum equation. Now sometimes this equation is also written as summation of forces multiplied by dt is equal to d of mv. This relation is also sometimes referred to as the impulse momentum relationship, which basically means that changing momentum of a flowing fluid in any direction is equal to the impulse of force in that direction over a period of time dt. Now, I have covered the momentum equation. Now let us consider the force exerted by a flowing fluid on a pipe bend. Now I have taken a pipe bend at an angle theta with the horizontal. I have taken two sections, one before the bend and one after the bend. Now I analyze this control volume enclosed between sections 1 and 2. Now at the section 1, the pressure is P1, the area of the cross section is A1 and the velocity of the flowing fluid is V1. Similarly, at section 2, the corresponding variables are P2, A2 and V2. Now, in this analysis, I have made a few assumptions. The first being, I have considered a flowing fluid which is ideal in nature. Now, whenever I say that this particular fluid is ideal in nature, I am referring to the fact that its viscosity is practically zero, which means the viscous losses or the frictional losses will be zero. And for this analysis, I have considered the gravity forces to be negligible. Now, let Fx be the force exerted by the fluid on the bed in the x direction and Fy the force exerted by the fluid on the bed. So vice versa, in employing a Newton's third law of motion, minus Fx is the force exerted by the bend on the fluid and minus Fy will be the force exerted by the bend on the fluid in the y direction. Now, rewriting my momentum equation, it is summation of forces is equal to d by dt of mv. Now, if I take a finite interval, I can write this as delta of mv by delta t. Now that is also equal to, now since mass is constant, I can write it as m delta v by delta t. Now, what is m by delta t? M is mass flow over a period of time delta t. That is nothing but mass flow rate. I will write it as m dot delta v. Now what is delta v? Delta v is the total change in velocity in the direction in which the summation of forces is taken. Now let it be, say, if I am talking about the x direction, I will just rewrite it as summation of forces in the x direction, that is equal to m dot times V final in the x direction minus V final in the, V initial in the x direction. Similarly, I can also write summation of forces in the y direction is equal to m dot V final in the y direction minus V initial in the y direction. I hope this is clear to all of you. Now before I proceed further, I just want to look at what is mass flow rate. Now mass flow rate is the total mass flowing per unit time. Now if I now mass can be written as rho times volume per unit time. Now that is nothing but rho into what is volume per unit time, that is nothing but volume flow rate, or sometimes also referred to as discharge. Sometimes also referred to as the discharge. So Q Capital Q is nothing but the discharge or the volumetric flow rate through a particular section. Now, by definition, volumetric flow rate through a particular section is nothing but the product of the area of the cross section multiplied by the velocity of flow. I repeat, the volumetric flow rate through a particular section Q, or what you call the discharge, is nothing but the product of the area of the cross section multiplied by the velocity with which the flow is happening. Now I'll proceed to my aim of calculating the force exerted by the fluid on this bed. Now just rewriting the previous equation, summation of forces in the x direction is equal to m dot delta v, that is rho q times delta v. Now since it is in the x direction, I will write delta v in the x direction. Okay, now what are the forces acting in the x direction? What I will do is I will go from section 1 through to section 2. Okay, at section 1 what are the forces acting? Since P is the pressure at P1 is the pressure at section 1, my total pressure force will be P1 into A1 acting in the positive x direction, hence taken to be positive. So P1 A1. Now at section 2, my pressure force is acting like this, P2 A2 at an angle theta with respect to the horizontal. So the horizontal component of this pressure force P2 A2 will be P2 A2 cos theta, and it will be inclined towards the, and will be acting towards the negative x-axis. Therefore, I will be taking a minus sign P2 A2 times cos theta. Now as per definition, Fx is the force exerted by the fluid on the bed. So using Newton's third law of motion, I'll have I can say that minus Fx is the force exerted by the bed on the fluid. So I'll put minus Fx as the force exerted by the bed on the fluid. That is equal to rho q times, now delta Vx, that is final velocity in the x direction minus the initial velocity in the x direction. Now the final velocity is V2. Now the component of this velocity in the x direction is V2 cos theta. So V2 cos theta, and the initial velocity is V1 acting in the positive direction only. So minus V1. Now rearranging this equation, I can write Fx is equal to P1 A1 minus P2 A2 cos theta plus rho q times V1 minus V2 cos theta. This is the expression for the value of Fx, the force acting, the force exerted by the bend on the fluid, that is the force acting on the fluid due to the bend. That is equation number 2. Now similarly, using the same relationship, I can calculate the value of the force acting in the y direction. Now again I will write summation of forces in the y direction is equal to m dot delta v in the y direction. So at the section 1, what is the value of the force acting in the y direction? There is no force. The only force is P1 A1, and that is acting in the x direction. So the force acting at section 1 in the y direction is 0. Now at section 2, I am having P2 acting at an angle theta with respect to the horizontal. So taking the component of P2 A2 in the vertical direction, that will be P2 A2 sin theta, and it will be directed vertically downwards or in the negative y direction. Therefore I will put minus P2 A2 sin theta. Now by definition, Fy is the force acting, a force exerted by the fluid on the bed. So vice versa, using your Newton's third law of motion, minus Fy will be the force acting on the bend due to the fluid. So minus Fy is equal to, again, mass flow rate m dot, that is nothing but the product of rho into discharge times velocity change, final minus initial in the y direction. Now the final velocity in the y direction is v2 sine theta acting upwards. So that is v2 sine theta minus the initial vertical velocity or initial velocity in the y direction. Now at section 1, the velocity is horizontal in nature, v1. So the vertical component of velocity v1 is 0. Rearranging this equation, I can write summation of forces in the y direction. The force in the y direction Fy is equal to rho q v2 sine theta plus p2 a2 sine theta. Not plus, sorry, minus. This will also be minus rho q v2 sine theta minus p2 a2 sine theta is equal to Fy. Now let us see equation number 3. Now I have got the component of the force Fx, I have got component of the force Fy, where Fx and Fy are the force exerted by the fluid on the bed. Now the total force can easily be calculated, that is total force F is nothing but square root of Fx squared plus Fy squared, and the angle alpha it makes with respect to the horizontal is nothing but tan inverse Fy by Fx. I hope you understood this. Please like and share. Thank you.